talk about the different types of testing we do in ONOS and the different stages of testing we do. So the first one I'd like to talk about is unit testing. Hopefully every one of you that is involved in writing code knows what this is. But in case you don't know, unit tests are tests for a small chunk of code. They test the inputs and outputs of a function. And this ensures that the code does what it says it does. And when you refactor the code, you don't break this contract. So the goal for our coverage for unit tests for new code is 70%. But the goal for the project as a whole is over 80%. So if you want to run a unit test locally, you can first build ONOS with buck build ONOS, then run the test with buck test. So it's always a good idea to run unit tests for the code that you've written before you push to Garrett. And then as part of the Garrett validation, this will also run in the cloud for each chain set that is submitted. If you want to learn more about how to write unit tests, what are guidelines we have, what are some of the conventions we use, there's a great wiki page on the ONOS wiki that you can check out. A great tool if you're interested in code coverage is Sonar. We have sonar.onosproject.org. And this measures code coverage per module. So you can see on the right is a tree map of the different modules, and the colors are based on the code coverage for that module. And if you click on each of the modules, you can drill down to the individual files. And then it will actually show you what lines of code are covered, which lines have partial coverage for branching statements. And then you can also see the coverage over time, as well as lines of code and technical debt, which is a measure of different code analysis warnings. We also have some GUI unit testing. So our GUI is in JavaScript, there's some JavaScript unit tests, and those run in the headless browser. If you want to run this locally, you can do npm install and then npm test. There's a README in the ONOS source code that explains more about how to write these tests, how to run them. And again, this is also run as part of the Garrett validation for any new code that's submitted. And then we have STC testing, which is integration testing. The STC stands for Scenario Test Coordinator. And these are short, simple system tests that can be run by a developer to quickly verify that they didn't break any major functionality when refactoring code. And these are modular tests, so you can compose several scenarios to create a new scenario. You can control ONOS through simple bash or Python scripts. And then this uses Mininet to create the data plane. To run the tests locally, you can do STC Smoke, which is a simple scenario that combines some of the more common tests, or you can write your own scenario in STC, whatever the name of the scenario is. And then a great way, if you find a bug that you can easily reproduce and you want to help developers reproduce the issue, you can write a scenario and submit the scenario with the bug report. And this will help the developer reproduce the issue, but also when they fix the issue, it'll help them verify that they've actually fixed it. And then there are several pages on the wiki under Appendix G that explain what Scenario Test Coordinator is, how to write new tests, how to write, or how to run the tests, things like that. So if you're writing code, especially if it's a major change and you want to verify that you didn't break anything, it's great to run this before you submit to Garrett. And we have plans to try to run this periodically, either on every commit or every couple of commits as part of the automated build process. Next we have ONOS system tests using TestONL. So these are some more thorough system tests. They're written in Python, so it's a little easier to verify some of the output. It controls ONOS through REST or CLI. We have 3 test suites. There's a functionality type of test, there's the longevity type of test, and then there's the performance and scale tests. If you want to run this locally, after installing TestONL, you can run CLI.py run and then the name of the test. And then these tests are run nightly in the lab, and they're used to help verify and validate new releases. So here's some resources. If you want to check it out, it's the ONOS system test repo is located in Garrett, the same Garrett as the ONOS project. It's just a different project in Garrett. And then there's a couple of system test wiki pages, so there's a guide for how to install and run these tests. And then you can also find all of our test plans and test results on the wiki. So the functionality type of testing we do, the idea is to focus on the core of ONOS and then move outward. So we have functionality or FUNC test suite, and this focuses on the networking aspect of ONOS. So it tests intents, topology, flow vectors, groups, those kind of things. We have an HA suite, which focuses on high availability of ONOS. So we test controller failures, cluster restarts, control network failures, partitions, and then in all of these tests, all the HA tests, we also test data plane failures. So switches dying, links disconnecting, things like that. And then we have use case specific tests. So these are tests for specific applications, so SNAP, segment routing, VPLS. Then we have the longevity testing. We call it CHO for continuous hours of operation. And this test usually runs for several days. The purpose of it is to catch memory leaks or other hard to reproduce defects. And then this test can run a random or a fixed series of events. Then we have scale and performance tests. These are focused on ONOS performance, and as part of this, we don't really want to care about other third-party actors that we can't control, such as switches, the network, things like that. So we use null providers, and these kind of mock out these elements. So we have a null device provider, and basically when you try to send something to a switch, the provider, instead of waiting for a response from the switch, it immediately returns to ONOS. And the idea is we break down a single event from an operator's perspective, individual ONOS events, and this helps us focus our development efforts on the parts of ONOS that are slow. And then we measure performance across different cluster sizes, so we go from 1 node, 3 node, 5 node, 7 nodes. So an example of a latency test is we have a mastership failover test. So when a node dies, an ONOS node dies, and the mastership fails or the mastership transfers over to another ONOS node, we break it down into a couple of events. So the first kind of time sequence is from when the node dies to when the cluster detects that failure. And then once from when the cluster detects the failure to when the cluster elects a new node as master of the device, and then the next step is when that new master sends a role request to that device. We have a couple different latency tests. We have topology events, intent events, flow events, host adding, master should failover. There's some throughput tests, in number of intent events per second, flow objectives. And we have a couple of other tests. We've done some integration with the Delta security testing in the past. The current version of Delta and the current version of ONOS don't play well together, and the Security and Performance Brigade is working on getting that test back up and running. We also have some simple Docker tests that basically just downloads the latest couple of images from Docker Hub, and then forms a cluster and verifies that the cluster can start. And obviously, this is a pretty simple test, and it's a great candidate for community contributions. And on that note, if you want to get involved, there are different brigades that I mentioned. So the build and package infrastructure brigade. If you want to get involved in the CI kind of framework, that's a great place to get involved. If you want to help write GUI unit tests, or if you're interested in helping write some end-to-end tests for the GUI, that's a great brigade to get involved in. If you're interested in the security performance, there's a security and performance analysis brigade. And then if your favorite app is missing a test, we can help you write the test. If you don't have time to write code, or you don't know how to write code, but you still want to help your app get tested, you can write a test plan. And this is great because there's always people who want to help get involved in ONOS, but they don't necessarily have the domain-specific knowledge. And if there's a test plan, it's very easy for them to get up and running. And you can always reach out to a brigade related to your application, or if there isn't one, you can form a new one with other people who want to either improve an application or create a new application. Any questions?
Anyone have any questions about the testing infrastructure? So John, what if you had your choice, what additional testing do you think you should do? What do you think is the place we're the most vulnerable?
I think probably application testing. We have a few applications, mostly ones that ONF has been involved in deploying. But most of the applications in ONOS right now don't have any, at least system level tests. And some don't have very good coverage with unit tests as well. So I think that's probably the next place to look at it.
Thank you, John.